is mathematics, and this is problem 22 of this year's AMC8, and it's a long one. I really hope Simon's favorite factoring trick will assist us with this one. A classroom has a row of 45 coat hooks. Paulina likes coats to be equally spaced so that there's the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? Well, we could just go on about finding all of the cases that satisfy this pattern, but that would be ridiculously boring. Also, that would take a lot of time, but more importantly, it would be boring. What if we turn this reading comprehension problem into a math problem? Let's establish some variables. Now, we're being asked for the number of different numbers of coats that satisfy Paulina's pattern. So we should have a variable C for the number of coats. Now, the number of coats is also equal to the number of occupied hooks on that row of 35 coat hooks. You have the occupied hooks, and then you have the unoccupied hooks. The unoccupied hooks come in the form of equal gaps between each coat. So we can say that there are E empty hooks per gap and G gaps. And now we can construct an equation with the number of coats, the number of occupied hooks, plus the number of unoccupied or empty hooks equaling 35. C plus EG equals 35. Yay, we have our equation. Let's move on to the next step. There was no next step. There's no first part of this left-hand side that we can factor and factor out the binomial. Yeah, we can't do anything. And either way, 3 variables is a little too much for comfort. Let's try to eliminate one of them. Now, the way that you do eliminate a variable is by expressing that variable in terms of another variable. So, you know what? Let's just try to express G, the number of gaps, in terms of the number of coats. So, we should illustrate a picture with a row of hooks and coats that follow this pattern to help us find this relationship. So let's just say that we have a row of 5 hooks. And we have coats here and here. That means that we have gaps here, here, and here. So we have 3 gaps and 2 coats. We have one more gap than the number of coats. Does that apply to all of the cases? I mean, see, the thing is that you can assign a gap to the coat that's directly to the left of it. So this gap will get assigned to this coat, this gap will get assigned to this coat, but this gap is left out because there's no coat to the left of it. That gap is an extra, which is why there will always be one more gap than the number of coats. So that means that the number of gaps is equal to the number of coats plus 1. And we can enter that in our equation and eliminate G. Let's distribute the E. And now, finally, we can consider the 2 binomials that multiply to make this left-hand side. We know that there must be an E term in the first binomial, a C term in the second binomial, because that E would distribute to that C, make the EC term. So there we have it. But then we have this E term that we have to make. Well, that's easy. E distributes to a +1 in this binomial. You have that. Same thing with this C term. This C distributes to a +1 here. Very good. Hold up. This +1 can distribute to this +1. So actually, by doing this, you are adding 1 to the left-hand side of this equation. So you have to do the same thing to the right-hand side. That means that this becomes a 36. And now we can consider all of the factor pairs of 36 and find values that work for E and C. Well, the first pair of factors that multiply to 36 is obviously 1 and 36. Where 1 is the value of E plus 1, 36 is the value of C plus 1. Slight problem though, if E plus 1 is equal to 1, E is equal to 0. And yeah, we need to have at least one empty hook. Unfortunately, this does not work. Now let's move on to the second factor pair, which would be 2 and 18. E plus 1 is equal to 2, E is equal to 1. C plus 1 is equal to 18, C is equal to 17. Yes! All of the problem's conditions are satisfied, so this does indeed work. 3 and 12. Indeed it does. E plus 1 is equal to 3 is equal to 2. C plus 1 is equal to 12. C is equal to 11. Yes. 4, 9. Yes, that works. 6, 6. That works. And actually, even the reverse pairs of these 3 factor pairs right here, they also work, providing satisfactory values of E and C. Now, the reverse pair of 1 and 36, that does not work because that actually makes C 0. We need at least one coat. So that means that we would have 1, 2, 3, 4 plus the 3 reverse pairs that also work for these values. That's 5, 6, 7. Therefore, our answer is 7. We have the answer. Yay!